myself, I am Sivapriya. I am working as an assistant professor in Marefram College of Engineering and Technology. Today we are going to learn the concept of measurement. Okay, what is measurement? It is a comparison between the standard and the thing we don't know. That thing we don't know, we want to understand the thing. It may be it may be a speed, or it may be a length, it may be a weight, it may be a temperature, it may be a time. The thing we want to know more about it is called a measurement. To measure, there should be a comparison between the two quantities, and the results must be expressed in numerical number. Say, without any numerical number, we cannot explain the thing in a detailed way. As we know, the height. Say, one person is there. We are saying that she is short, she is tall, or is normal height. But when we are saying like she is 153 centimeters height, that gives more detail. Or say as she is 60 kgs of weight, rather than saying she is okay, normal, or some other terms, some other objective terms. But when we say in number, it gives a complete understanding of the quantity we want to express. So when we are measuring, we want to know the unknown parameter with the number value. Meaning, say the height we want to express in number with the unit. Okay. The basic requirement for the meaningful measurement is we have one standard and the method to acquire the value. The two things are there. The standard should be commonly accepted and accurately defined. That is the main requirement for the standard. And for the method to acquire the particular value, the method we use to get the value should be acceptable and provable. That is very, very important. Why we need this measurement? Why we are very interested in measurement and instrumentation? The main objective of the engineering domain is designing equipment to get the system done a particular job, or controlling some process so that we get the maximum of yield. For all these our objectives, we need some values. We need the status of the system, or we need what is the current performance, so that we can design, we can understand the system, and we can introduce a certain new modification so that the system will perform as we required. So the measurement is irrespective of any domain. The measurement and instrumentation is very common to all the engineering disciplines. Okay, what are the methods we used for the measurement? To measure, we use the direct methods and indirect method. The direct method is we want to measure a current. We measure a current directly. If we measure a current directly, and the current is the thing we want to measure as well, then this is a direct method. In indirect method, we want to measure a strain, but we measure a resistance change, or we measure a voltage change inaccurate, and then we convert to the strain. Then it is called the indirect method. What are the types of instrument we are using to get the measurement done? There are three types of instruments. They are mechanical instruments, electrical instruments, electronic instruments. In the starting of engineering era, all the devices are mechanical in nature, so as the instruments as well. The mechanical instruments are very reliable and very safe for the static or stable conditions. Meaning, static condition means the change of the parameter is very low frequency in manner. But dynamic, when we come for the dynamic, the changing of the parameter is very rapid. Say for example, for static condition is temperature change throughout the day. It is almost static. It also changes very slowly in low frequency manner. In those kind of application, the mechanical instruments are very reliable and very accurately provide the reading. But what is the disadvantage of mechanical devices is they are unable to respond rapidly to the measurements of dynamic and transient conditions. So the next type of instrument is electrical in nature. They are more accurate and faster than the mechanical, but the indicating output is more of mechanical type, so that they cannot provide very accurate results. The third type of instruments are electronic instruments. The example for electronic instruments are nowadays we using digital voltmeter, digital multimeter, DSOs are example for electronic devices. They are more reliable than other systems. They use because they use semiconductor devices. The semiconductor devices works on electron level, so that we get very accurate results, and the weak signals can also be detected, amplified, processed, so that we get the maximum of output from the maximum of details from the results. Okay. Also, the instruments are classified depending on absolute instrument and secondary instrument. The absolute instruments give the magnitude of the quantity under the measurement in terms of physical constants of the instrument. While in case of secondary instrument, these instruments are calibrated by comparison with the absolute instrument which already been calibrated. Okay. Then next, depend on the functions of instrument, the measuring systems classified into three. They are indicating functions, recording function, controlling function. If in a room we have a thermometer which indicating the current temperature of the room, then that device comes under the indicating function. Also the time, the clock, which is an indicating instrument, it shows the current time, nothing else. That these devices comes under indicating function. The recording function, say example for the energy meter in our home, they are energy meter in our home, they indicate the value as well as they record the value, so that we can measure how much amount of electricity we have consumed. Okay. The third type of instruments are controlling function. They used to provide the value for the actuating devices. Okay. The next, based on the point and moment, the instruments are classified as deflection type instruments and null type instrument. In null type instrument, the correct value, when we get the correct value or when we get the balance, the pointer comes to the zero position. In deflection type instrument, it shows the value of the quantity we want to measure. Okay. The application of measurement systems are, they used to monitor the process and operation, they control the process, and they also use for experimental engineering analysis. In experimental engineering analysis, if a parameter is very new to us, or the current there are new engineering concepts are evolving, the also the measuring instruments also evolving for that particular purpose, they comes under the experimental engineering analysis. Okay. The instrumentation system further classified based on their applicability and based on their purpose, they classified as intelligent instruments and dumb instrument. In intelligent instrument, the data we are acquiring, it is defined for the purpose of presentation itself. The device itself present the data in a manner we want to get. In dumb instrument, the instrument only provide the data to the observer. The observer has to prepare his or her presentation, because the data are very raw. And the very important understanding of instrumentation system comes with its block diagram. For all the measuring instrument, there are these 5 functional blocks are either merged or separately available. First, the primary sensing element is the very important element in the measurement system. This part detects the signal or understand the variable we want to measure. Then after the primary sensing element, the variable conversion element comes. Then next is variable manipulation element, and the data transmission element, and data presentation element. These 5 elements classified as 3 stages. First, primary sensing element is detector and transducer stage. Variable conversion, variable manipulation, and data transmission element comes under intermediate stage, and data presentation element is a terminating stage. First, primary sensing element. The quantity and the measurement makes its first contact with the primary sensing element of the measurement. It's a initial, it's like a reception. Okay, next, variable conversion element. It converts the output of the primary sensing element into the suitable form to preserve the information in the original form. Okay, data in presentation element, the data is presented so that the observer can understand the overall process or the requirement of the observer. Requirement of the observer is tallied by the data presentation element. If the observer want to know the current status, then the data presentation element shows the current status only. If the observer want to see what's the history of this particular value, then the data presentation element will be chart or graph, so that we can see how the variable gets changed, so vice versa. Next, these instruments have some static and dynamic characteristics. The example for static characteristics are accuracy, drift, dead zone, static error, sensitivity, reproducibility, static correction, scale range, scale span, noise, dead time, hysteresis, linearity. One by one we will see in the next. Accuracy. It is the closeness to the instrument reading approaches to the true value of the quantity to being measured. Accuracy is the error mostly expressed in terms of accuracy. So the accuracy is that how close the value gets to the true value. Because if the device is very accurate, the actual value get displayed in the instrument. When we get a very accurate device, we get the actual result. The accuracy is defined in terms of error, as we mentioned. It has a true value. True value meaning the quantity we want to define, we want to measure. What is the actual value present in a particular instant is a true value. How the true value is measured? True value is measured by the theoretical way mostly. The next is sensitivity. Sensitivity is defined is a ratio of our ratio between output response to the input response. Next is static error. Error is a difference between measured value and true value. Here AM is a measured quantity at the particular instant, and AT is a true value of the quantity at the particular instant. This while we are defining error in this way, it is called absolute static error. Next, in measuring instrument, we see the scale range. Scale range is in a display instrument or a digital instrument, how minimum value that can show and what maximum value it can show. Say for example, in digital meter having 3 digits, 3 digit space, then what is the minimum value it can express? It can express 0 0 0 as a minimum value, and the maximum value will be 999. Next, scale span. Scale span is the difference between the maximum value it can show to the minimum value. In the above mentioned example, the maximum value is 999 and the minimum value is 0 0 0. What is the scale span? Scale span is 999 minus 0, which is 999. Next, the term reproducibility. Reproducibility is specified in terms of scale reading over a given period of time. The next is drift. Drift is an undesirable quantity in an instrument, because while we have drift, before we start using the instrument, we have to adjust the drift, or we have to account the drift already had in an instrument. So drift are 3 types. They may be a zero drift, span drift, zonal drift. Okay, the dynamic characteristics of the measurement system. We have seen the static characteristics of the measurement system. They are accuracy, drift, dead zone, static error, sensitivity, reproducibility, and other terms we have discussed, or some of the terms we have discussed. And in dynamic characteristics, it comes speed of response, measuring lag, fidelity, and dynamic error. Speed of response, because when we say a word dynamic, we have to understand that the parameter or the measurement we want to know getting changed very frequently. The change in a parameter is very fast. So the speed of response, that parameter is very much important when we are measuring a dynamic measurement. It is defined as a rapidity with which a measurement system responds to the change in measurement quantity. It is one of the dynamic characteristics of the measurement system. Next is fidelity. It is the degree to which the measurement system indicates the change without an error. That is the fidelity. The dynamic error is actually error, but when we measure a dynamic parameter, the error terms is dynamic error. The next is measurement lag or measuring lag. Lag. It is the retardation delay in a response of the measurement system to changes its measured quantity. There are two types, retardation type and time delay. Okay, it's a very important to understand the measurement system. What are the types of error can occur in a measurement? The errors classified as a grass error, systematic error, random error. In systematic, there are three types of error: instrumental, environmental, and observational error. Grass error is simply a human mistake. We see some reading but we write some other reading. We see some reading, we say some other reading. So say for example, I am measuring in a voltmeter, the digits getting fluctuated in a least significant bit. What we are saying, say for example, it says 1.05, 1.07, 1.08, 1.9, 1.1. Then the observer cannot say what is the value. He will say some middle ground. So these errors comes under grass error. What should have been done? He has to write all the value and take the average. That is the acceptable way of doing that. Otherwise, the grass error occurs because of mainly a human mistake. And the next type of error is systematic error. They are instrumental error, environmental error, and observational error. The instrumental errors because of the shortcoming of the instrument, misuse of instrument due to the loading effect. These are main three reasons to get the instrumental error. And next, environmental error is the condition, the environment we want to measure. And because of that, say for example, temperature, pressure, humidity, EMF, dust, some other external factors contribute for instrumental error. The observational error is that the observer should see, in case of pointer, is a perpendicular to the pointer. If he is seeing some another angle, he will see some other value. That is the parallax error. It is an example for observational error. Next is very important error. It's a random error. We never know what is the reason for the random error. Or we might have known, we might have guessed some reasons, but those reasons are those reasons contribute very small factors, but many other reasons we never know of. The random error caused by some fluctuations, they are the thousands of reasons, but each reason contribute very minimal. We cannot try to eliminate that error. We cannot eliminate it. That is the reality. So this is the random error. How to reduce the random error? We might have take arithmetic mean of the values, or we find the deviation, we find the standard deviation, we use variance to understand the random error in a measured value. Also we can find the probable error. This is one example. For the observer make 10 observation, taking us, we are not changing the input. For a constant input or for a constant environment, the meter shows the following reading. We have to find the mean, standard deviation, probable error and range. So we have to use these formulas to observe the reading. Okay, the next important is calibration. So we have designed a perfect instrument for measuring a certain value. Over a period of time, we cannot give the assurance. So we have to check the meter with the standard. That is the process of calibration. We may have or the standard may be a primary standard or a secondary standard. What is the meaning of standard? Standard is a physical representation of unit of measurement. Standard applied to a piece of equipment having known measure of physical quantity. It's very accurate device is a standard device. There are 4 types of standard. They are international standard, primary standard, secondary standard and working standard. Normally working standards used in a laboratory, secondary standards is in industrial laboratories, and the primary standard is a national level. International standard is they are all over the world. They have the international standard of unit, those standards. And thank you very much for listening this. I hope you understand it. In this video is used for the purpose of revision only. So already these terms are explained to you. If you have any doubt, let me know. Thank you.